Hi, this is 7.5. We'll be factoring polynomials, specifically in the form of x squared plus bx plus c, or it's also referred to as factoring quadratic trinomials. Even more specifically, factoring quadratic trinomials where the leading coefficient is 1. So notice we have three terms here that I want to factor. It's quadratic because the degree is 2. That's also called quadratic. And then the leading coefficient is 1. Let me just show you a couple of examples first. And a lot of times when I show people examples, they'll figure out exactly the process on how to factor a trinomial like this. This would factor into x plus 4 times x plus 2. Or it could also be x plus 2 times x plus 4. It actually doesn't matter. But what we're trying to do here is basically the opposite of FOIL, or the opposite of distributing. I'll go through a couple other examples, and then we'll go through the process on how to factor completely. Okay, so looking at the next couple of examples, x squared plus 9x plus 20, that would factor into x plus 5 times x plus 4. Or again, it could be x plus 4 times x plus 5. The order of the binomials actually doesn't matter. The signs do matter though, however. Number 3, or example 3, x squared plus 10x plus 25 would factor into x plus 5 times x plus 5. Or I could rewrite that as x plus 5 quantity squared. And then on example 4, here's where the signs are very important. X squared minus 3x minus 40 would factor into x minus 8 times x plus 5. Or again, it could be x plus 5 times x minus 8. But here's what we're really looking at. For all of the examples that we just went over, we're taking a trinomial, again, a quadratic trinomial where the leading coefficient is 1, and then trying to factor that into the product of two binomials. But the order that you look at things in is not really from left to right. It's actually the first term. The first term here is x squared. So if I'm building my binomials, besides knowing that I'll factor into x plus 4 times x plus 2, the first term of each binomial has to multiply together to give you x squared. So that's x times x. Then you want to take a look at the last term, 8. The last terms of each binomial should multiply to 8. So there's a few options there, like you want to find the factors of 8, 8 and 1. Those are factors of 8, and 2 and 4. Or you could also say 4 and 2. Those are the only factors of 8. But the factors of this 8 here have to add to this middle term here. So the only factors of 8 that add to 6 are 4 and 2. 8 and 1 don't add to 6. They add to 9. And then the same for example 2. For x squared, that's how we got x and x. Then I look at the last term, 20. Factors of 20 are 20 and 1, 2 and 10, or 4 and 5. And only one pair of those factors add to this number right here. Add to 9, it's 5 and 4. 10 and 2 don't add to 9, nor do 20 and 1. Okay, and then example 3, kind of the same. For x squared, it's x times x. The factors of 25 that add to 10 are 5 and 5, not 25 and 1, which are the only other factors of 25. And then on the last example there, x squared minus 3x minus 40. Again, for the first term of each binomial, they have to multiply together to give you x squared. Not only do I want to look at the last term, but I want to make sure I'm looking at the sign as well. So the factors of negative 40, if I'm looking for two factors that multiply to negative 40, one has to be positive, the other has to be negative. If they add to negative 3, the larger of the two numbers has to be negative. So the 8's negative, the 5 is positive. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. Okay. And then really what I could do to check if this is factored correctly is kind of work backwards. If I FOILed this out, x times x is x squared. X times 5 is 5x. Negative 8 times x is negative 8x. And negative 8 times 5 is negative 40. If I combine these like terms, it's x squared minus 3x minus 40. We end up with what we started with. But if I'm asked to factor, this would be the correct factorization. All of this work right here is just to check and see if that's the correct factorization, and it is.